kindly take your books out. Yesterday we got a little far, not very far, but we did a little bit. Guys, okay, so again, we went through methods of data collection. We said we could observe, do a study where we just observe and we record what we see. We could perform an experiment, which is usually we administer something to somebody or do something to this group, and we generally have a control group that we don't do anything to. And then we test amongst them. We have a simulation, which says if it's too dangerous to do something or to put someone in a bad situation, we can simulate it. And we use a survey to gather our information. If it's for a whole population, we use a census. If it's for a portion of the population, we use a sampler. Okay? And so forth. Where we left off, I think. We did this. I think did we do this together? Did we do the other one together? The 70 patients and 70, the placebo effect? Okay. Okay, so here. Determine whether the study is an observational study or an experiment. The Pennsylvania Game Commission conducted a study to count the number of elk in Pennsylvania. The commission captured and released 636 elk, which included 350 adult cows, 125 calves, 100 branched bulls, and 51 spikes. Is this, yeah, no, I didn't know there were that many different kinds of elks. Is this an observational study or is this an experimental study? What do you say, Devin? Observation. God bless you. Anybody else? Experiment. Okay, so did they do anything to these elk?
Yes.
What did they do? They captured them and released them. So did they actually do anything to them?
Yeah, they tagged them.
Give them anything? Well, they probably did tag them, but did they administer anything to them that we would have to keep track of? Well, because all they really did, guys, all they really did was just keep track of them. If I wanted to figure out how many males and females were in this class, I would just have to count you, right? Capturing your elk and tagging them to see what they are is basically the same thing. It's just observational. Nothing is being given to them. Nothing is being done to them. We obviously don't influence them. All we're doing is counting them. So it is observational. So if you think experiment, say to yourself, is there a control group? Is there a group that's not getting something? What did they give them? What did they do differently? They didn't do anything differently in here. Well, the information is just they categorize them. They just categorize them. So it would be the same as like if I sent out a survey to everybody and I said, are you male? Are you female? What age group are you? Like maybe I would put you in ages. Are you 16, 17, 18? Check them. Do I do anything to you? So you just respond, I'm a male, I'm 16. I would have to capture you, yes. I would have to take your survey and say, okay, James is a male, he's 16. I check him off. Okay. Kevin is a male, he's 17. I check him off. But I don't, and I put him back. I put him back into the population. I don't do anything to them. We're not giving them anything that we can monitor. The fact that there are all these different kinds is just the same as just categorizing them. Okay. In experimental design, there are 3 key elements that make or break your experiment. One of them is control. If you don't have control of your experiment, think of science. I always tell the kids, think of your science experiments. Because when you're in a lab and you're doing an experiment, everything has to be controlled. You want to make sure you take care of everything. One of the things to be careful of is your variable. This is what you're testing, your variable. If you bring too many different factors into this, it can change the effect that it has on your variables. We call those confounding variables. So don't have too many different factors that actually affect your variable. So say I'm giving somebody a new sleeping pill, and I say, take this sleeping pill. If you have trouble sleeping at night, take this sleeping pill. It will give you 8 hours of sleep, and you will wake up refreshed. So all I'm giving them is a sleeping pill. This control group, no sleeping pill. I'm just giving them a fake pill. But say to the both groups, I said, oh, and sleep with this pillow. It's a nice soft pillow. It's a design so that it comforts your head and makes you relax. And I'm also putting those gel things under your mattress so it cools you while you sleep, so you won't be hot when you sleep. So am I really testing the effect of the pill? No, because maybe my problem was I get hot all night long. So this little gel thing is cooling me off, and that's all really I needed. So if there's too many things going on, it confounds the effect of your variable that you're testing. So the pill that I'm testing may not be the answer to their problem. Maybe it was their pillow. Their pillow wasn't comfortable, and they just didn't realize it. So keep track of your confounding variables. Placebo. Remember the placebo effect. When I give this other group this big pill and they think it's a sleeping pill, they may sleep better because people react better when you say, oh, I'm giving you something to make you feel better. So right away you take it and you say, oh, I feel better. You know, it's a placebo effect. Placebo effects statistically wear off, but sometimes it takes a little longer than your results are there for. So you got to be careful of your placebo effect. Blinding. We do a blinding, a single blind, and a double blind. You should never know that you're the group that's not getting the real medicine or the real gel cushion or whatever it is you're testing. That's called a blind. When the people that are getting this, the recipients, they don't know what they're getting. They all think they're getting the right one. They don't even know that there's a possibility that they're getting the wrong one. Everybody in this group knows they're getting this. Everybody in that group knows they're getting this. No one knows that there's even a possibility that you might have the wrong one. Double blind means the person who's running this experiment, the experimenter, doesn't know who's getting it either. They don't know either. Does anybody in here watch House? Remember House being on? I don't know if you remember 13, the Dr. 13. She had some kind of a debilitating disease, and one of the other doctors put her in this study, and it was supposedly a double-blind study that the people getting this extra medicine didn't know what they were getting. There was different groups, and the people administering it didn't know who was getting it. And the doctor wanted to make sure she was in it. And somehow, and it's totally illegal to do that, especially in a medical one, but he went and made sure that she was in the group that got the medicine. So you got to be careful with blinding and double blind. The reason they double blind is so that the administrator has no effect on their groups. You might kind of favor the group that's getting this because that's the group you really are testing. You want to see what effect they have. So if I'm giving this group this sleeping pill, I might be saying, you're going to have a great night's sleep tonight. It's going to be nice and calm when you sleep. In this group, I'm going to say, here, take this pill. You'll sleep better. Because I know they're not going to sleep better. So sometimes a double blind is a good thing. Randomization. Everything we do in statistics, finding our samples, population, has to be done at random. There can be no bias in here. Everything has to be done randomly. These are the three things that will make or break your experiment. Sometimes what they do is they put things into blocks. It's got kind of separated over here, but sometimes they put things into blocks. If I'm testing male against female, so I look at my male group, I look at my female group. Maybe this pill has a different effect on males than it does females. Sometimes it affects people differently. So what I might want to do is take my females and make two groups out of that. The group I give the pill to and a control group that I don't give it to. Take my males and make 2 groups out of that. I want to test the effect within that group. So those are making your assigned blocks for that. Another thing that you want to make sure you do is repetition. You want to repeat this process as many times as you can. And sometimes time is a factor, cost is a factor. So maybe you want to change your sample size and make it a little bit bigger. But you want to make sure you have enough in your sample size to make this be valid. And you want to repeat this enough times. So for instance, a company wants to test the effectiveness of new gum developed to help people quit smoking. Identify a potential problem with the given experimental design and suggest a way to improve it. The company identifies 10 adults who are heavy smokers. 5 of the subjects are given the new gum, and 5 of them are given a placebo. After 2 months, the subjects are evaluated, and it is found that the 5 who were using the gum have quit smoking. Is this a good design? I do have a group and I do have a control group. One is getting the gum, one is not.
Not enough people,
It's only 5 people in each group. Not enough people. I could have picked the 5 that were dead set on quitting smoking. Regardless if I gave them the gum or not, they would have just quit smoking. So 5 is a very small sample size. Very small. If you want to keep your 5, then I suggest you do this like at least 10 or 15 times with 5 different people. And they've got to be from the same population. The company identifies 1,000 adults who are heavy smokers. The subjects are divided into blocks according to gender. Females are given the new gum, and the males are given the placebo. After 2 months, a significant amount of the females have quit smoking. Any problem with this? Michael?
There should be males and females.
Yeah, I would mix males and females together because males and females generally behave differently. So sometimes when you give somebody something new, especially, hopefully none of you are smokers, but if you know somebody that's a smoker and they've tried so hard to quit smoking, and you give them something that you tell them, oh, you're definitely going to quit smoking, some people are more apt to decide this is it, this was meant for me to stop smoking, and they'll stop smoking. So you want to definitely, as Michael suggested, mix your males and your females. So read this one. It relates back to company 2 who gave them the gum. So read this and see what you think. Is 240 a good amount of people? Okay. So now they didn't do females and males. They must have mixed them, right? So they took care of that problem. So they randomly assigned them. They used a random method. Each subject is also given a DVD featuring the dangers of smoking. After 4 months, most of the subjects in the treatment group have quit smoking. So, is there any problem with it? Confounding variable. And what is the confounding variable here? The DVD. Good. So this DVD, in addition to their gum, if I'm testing the effect of their gum, the DVD could, yes, also. Especially if it looks really bad. If it looks like those commercials that are on TV, they're horrible. And it definitely will affect them. Okay, so you've got a confounding variable in here. So that just says watch for these things. Now, basically, this is really the extent, just this little unit right here is the extent of what we do on sampling and setting up experiments. Um, this in itself is a whole field of study. Because if you realize, just from these little examples, if you set up your groups incorrectly and you run this study, could be 2 months, it could be 2 years, it could be 20 years. If you didn't do the work up front and make everything the way it's supposed to be, your study is not valid at all. And it could take you quite a few years and a lot of money to decide, oops, something was wrong. Okay. We just did data collection, so getting into sampling techniques, how do we find our samples? So this is important too. In sampling techniques, you can sample your whole population or you can sample part of your population. One of the things you have to be careful of is that your sample is a good representation of your population. We call a sampling error the difference between the results of a sample and those of the population. Population, we have no problem with. We get everybody. We get every possible scenario. Sample, we might not get every possible scenario. It's done at random. It just might be the way it happens. Same thing when you flip a coin. Technically, your coin said 1/2 of the time. If you flip the coin 10 times, do you always get 5 heads, 5 tails? No. It's a random thing. So sometimes your sample is not a good representation of your population. So you have to be careful of that. We have 5 different ways to collect samples. Remember, they're always random. They're always done at random. But we do have one that's called a random sample. A random sample says every member of the population has an equal chance that I select them for my sample. There's no bias at all. One of the more popular random sampling ways is called the simple random sample. A sample in which every possible sample of the same size has the same chance. In other words, out of a group of 100, I'm going to take a sample of 20. I'm going to throw them back in, take another sample of 20, take another sample of 20. Every sample that I take of 20 should have the same characteristics, the same chance of being there. One of the ways we use random sampling is through a number generator. And this is in your book, in the back of your book. Can you get it? Yeah. If you turn to page, in the back of your book, it's on A7. A7 in the back of your book, right before the blue page. It's called a table for random numbers. Your calculator also has a random number generator. So what happens with your calculator is every time you reset your calculator, it resets the random table to the very beginning. So it's not that random. But the random table generator says this. There's just a bunch of numbers at random. So let's look for an example. Say I want to, out of my 30 kids in here, I want to get 5 kids. So what I do is I go around and I assign everybody a number. 01, 02, 03, 04, all the way up to 30. I take my random table. I can start anywhere I like. So I'm going to start right here. So I block out 2. I just keep blocking out 2. And now, I go through. Do I have a 23 out of 30? I'll take that person. Do I have an 89? No. Do I have a 43? No. 77? No. Do I have number 8? I'll take that person. 79? No. 86? 27? Yes, I have a 27 in here. 45? 78? It might take me a while. Here's a 15. I have number 15. These are totally random. Random number generators. You assign a number, and then you go through your table and pick one. If I had 800 people, how many digits would I have to go? 3. So I would say 3, 3, 3. I would say, do I have a 926 out of 800? No. Do I have a 307 out of 800? I'll take that person. So a random number generator using a table works nicely. There's no bias. There's no way you could know who is in there. Okay. Your calculator also has a random number generator, and we'll talk about your calculator in a minute. Another way we do this is called the stratified sample. Think of a stratified rock. A stratified rock has layers, right? It's usually compressed over time. Like it has sandstone and then gravel and then something and then it has different layers. It's stratified. Same thing with your sample. Your stratified sample contains some members of every part of your population. So for instance, this high school consists of freshmen, sophomores, juniors, and seniors. If I wanted to take a sample from this whole high school, I would probably use a stratified sample. At random, I would take 10 freshmen. At random, I would take 10 sophomores. At random, I would take 10 juniors. And at random, I would take 10 seniors. And I would have each group represented randomly. That's stratified. Cluster is a little bit different. Cluster says sometimes your group kind of naturally separates, such as your high school. I'll just take all my sophomores and look at them. Or I'll take all my seniors and look at them. I have to take one group only, but take all of them. Something that works real well in this is zip codes. Because the way all the towns are separated, everybody has a zip code. So I could say, okay, for this area in New York, I'm going to take 12553, 12518. I'm going to take those zip codes and take all of the people in those zip codes. Systematic is another way. Systematic is what they use in your gym sometimes. You're all lined up and they say count off. 1, 2, 3, 1, 2, 3, 1, 2, 3. I'll say, I'll take all the ones over here, all the twos over here, all the threes over here. That's systematic. The bad part about systematic is, what do when you see them counting? And you want to be on your friend's team. Yeah, you kind of just say, oh, quick, I'll be a 1, you be a 1. You know, and you set it up that way. So that's got a little bias in there. But a true systematic is just to go down the list and assign everybody 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, whatever it is you're doing. That's systematic. And the last one is one that we don't want. It's called the convenience sample. This consists of bias. This is where you kind of are picking your subjects. If you're doing a survey, and say I'm doing a survey to say, should we redo the bleachers? Should we fix the bleachers? And if I go to the gym, I'm at gym, I play football, I go to the gym, I ask all my football players, what do you think? Should we redo the bleachers? What are they going to say? Absolutely. They live on the field, right? Absolutely. If I go to the library and I randomly pick people there, are they more apt or less apt to say, yeah, let's fix the bleachers? It depends who I ask, right? So that's more randomized over there. So I don't want the bias. I don't want to ask my friends. I don't want to go to the ocean and say, and ask everybody at the ocean, what do you feel about water pollution? They should feel pretty strongly, right? They're sitting at the ocean. So I want to make sure I ask a random group of people these questions. So you have 5 methods, 4 really valid ones, 1 you want to avoid, the convenience one. Okay? So let's take a look at some of these. We have an example. There are 731 students currently enrolled in statistics in your school. You wish to form a sample of 8 students to answer some survey questions. Select the students who belong from your simple random table. So if you go to page A7 and you started at any line, how would you separate this to find 8 students? All I want to do is get it started. So if I pick this row, how would I separate this? Out of 731 students, I want 8 of them. Every 3. So I would assign everybody a number, and I would go every 3. Remember, I have 731 students. So I would go through. Do I have a 926 in my 721? No. Do I have a 307? I'll take that person. Do I have an 824? Do I have a number 19? Do I have a number 267? Do I have a 954? Do I have a 575? A 349? A 723? An 894? How many do I have? 1, 2, 3, 4, 5, 6. I need 2 more. A 377 and an 87. There's my 8 people. Completely at random. I just assign everybody a number. They could be in alphabetical order as long as I assign them a number. And then I go through the table. If you have 79 people, how many would you block off in your table? 2. Okay? And we would block off 2. And at random means you can pick where you want to start. You can pick where you want to end. You are doing a study to determine the opinion of students at your school regarding stem cell research. You identify the sampling technique if you are using. If you select the sample listed, discuss your potential bias. You divide your student population with respect to majors, and you randomly select and question some students in each major. Remember, this is a college course, so when they talk about like majors and stuff, they're talking about as if you were in college. So you divide your student population. I've got a math major, a science major, a psych major, and you randomly select and question some students in each major. Which technique is that for sampling? I have math majors, science majors, psych majors, phys ed majors, engineering majors, computer majors. These are all the majors in my school. I randomly select, I'm going to take 10 of these, 10 of these, 10 of these, 10 of these. Which sampling technique is this? Not simple random. I'm going to select some of each one. Stratified. Very good. This is stratified. I select some layers. Some of each layer. Do I represent every group that way? Every major then is represented in my survey. Here's another one. You assign each student a number and you generate random numbers. You then question each student whose number is randomly selected. Now, this is your random number generator. You select students who are in your biology class. Could be a cluster. Could be a cluster because you're just selecting one group, but they're in your biology class. Convenience. This is the key. If I selected, how about this? How about if I selected only biology majors? That would be a cluster. But in my biology class, this is convenience. Okay. Then I'm asking it where it's convenient for me to ask. Okay. All right, think about these two. You select a class at random and you question each student in that class. Everything is done at random. Always, though, you probably will always see the word random in there. What did we just say? We just took every biology student. Cluster. So you select a class at random, any class at random, and you just do that whole class. Cluster. Cluster. What is a cluster of stars? A lot of stars, and aren't they all put together like this? So there's all the stars up in the sky when you look up, but you just see a cluster. It's all the ones from the same little group. Try to remember it that way. That instead of testing all these other stars, I'm just going to ask this whole cluster, this group right here. That's a cluster. What technique, what sampling technique are we using if we assign each student a number, and after choosing a starting number, we chose every 25th student? Systematic. Good. So these are really, really important. We did 4 data collection methods. We did 5 sampling techniques.